All right, so hello again. In this video, I'm going to show you how to draw pictures using Python's Turtle Graphics module. This module is used primarily for educational and learning purposes. It's mostly just sort of fun to play with. It's not a data science library. This doesn't get used sort of in real world situations, really. And so it probably isn't going to show up again in your life, other than the fact that it's really fun and it's a good way to practice doing programming concepts and being able to do this kind of learning. And so we're going to do a little bit of it today. All right, so first some context. So Turtle Graphics is a process that's used for creating computer art, and it exists in really most every programming language in some form or another. Python is one of the better implementations of it, though. So Turtle Graphics is based on work by computer scientist and educator Seymour Papert. They did in the late 1960s at MIT. What Papert did is he built a robot, which you can see sort of in the corner of this picture here, which looks a little bit like a turtle, sort of round. And he built this robot to help teach children how to learn to program computers. So the robot has a pen attached to its butt, and so that whenever the robot moves over a piece of paper, it would drag the pen along the piece of paper and therefore effectively draw a trail, right? So as the pen moves on the paper, it draws a trail of where the robot went. So the children would then program the robot like where they want to go, how they want to turn, what kinds of movements they want to make, leaving a trail behind them, and then in effect drawing a cool picture on the screen. So with Python's Turtle module, what we're going to go over today, you're going to be able to program a virtual robot to basically do the same thing, to drag a virtual pen across a virtual piece of paper in order to then be able to draw pictures however you'd like. Okay, so actually using the Turtle module in Python requires a tiny bit of care and setup using the computer setups that we've sort of established so far in this course. So the issue is that the turtle draws its picture in a separate window. It doesn't draw it sort of directly inside Jupyter. And because Python's windowing system is really kind of finicky, it takes a little bit of setup, particularly on a Windows machine, to be able to get the turtle to work in a way that's going to work well for us. So in order to try to make working with the turtle easier, I'm going to generally be providing you with a Jupyter notebook that'll have sort of a bunch of setup code in place that'll get the turtle to do the thing that the turtle needs to do. So this notebook will be available below this video in ed, and then turtle-based assignments will have sort of the same set of code up and running, ready to go. So I'm going to get you started using that notebook, and I'll be the example we're going to use for the demo today. However, in order to open up this notebook, we need to do it in a pretty particular way on Windows. So I have my notebook sitting inside this turtle demo folder. Right, there's my turtle demo i.py notebook. In order to open it up on Windows, we're going to need to open up using either the Anaconda prompt or git bash. You can't use the WSL, the Windows Subsystem for Linux, to open up this turtle stuff because effectively Windows Subsystems for Linux has its own windowing thing that it takes a bunch of extra work to get set up, and we're not going to deal with that because that's way too much work that we want to do it. So we're going to the best way to do it, easiest way is to open up through Anaconda prompt. So if you go select on your search bar here, to be able to open what we want, we're going to open, if we look for Anaconda, you should then, if you have Anaconda installed, you should have a link to the Anaconda prompt, which is going to be a command prompt that sort of got Anaconda all set up and ready to go and install. We showed that off earlier. So if we click on that, that'll let us open up the Anaconda prompt. It'll take a minute to load, and we're going to wait in real time because I'm not editing it. There we go. So I'm going to then change directory to my desktop. I'm going to change directory to my turtle demo. I'm doing exactly what I normally did on the command line, and then I'm going to use Jupyter Notebook to open up this particular folder. So again, this is going to be the exact same process we've used normally for opening up a Jupyter Notebook, except we want to make sure we're not opening it up through the WSL. If you try to open up through the WSL, things are not going to work very well. The whole thing is going to sort of fall apart. All right, let's see. Is it going to open up a browser? It looks like it is. Okay, great. Go. Ta-da! There's our Jupyter Notebook. We can open up our the actual notebook to look at. Wait for it. There we go. Great. Cool. So Once you've got this open, you're going to see a bunch of provided code, and it's going to look long and intimidating. The key here is to just don't worry about any of this. This is basically me defining a bunch of functions that are going to help get the turtle set up and ready to go and work well without you having to do any extra setup work. So you can just focus on basically saying turtle go left, turtle go right. So what we're going to need to do here is we've got 2 cells of content. We're going to need to go to our first cell. We want to make sure we select that and then do Shift Enter in order to execute it. So we want to get that up and running. You'll see that 2 buttons appear at the top. Don't click those yet. We're going to use those later. But effectively what this does is this defines some functions that will let us be able to establish and set up the turtle and its paper, its canvas, its window for it to draw. You can then actually create that by calling the make turtle function that I defined up above. Specify how big you want your window to be and like a name you want to go on top of your window. And this will then return the turtle that you can draw and tell to move around. So we can go ahead and we can execute that. And what this should do is this will open up a new window. Now here's the trick. This is where things get really sort of yucky on Windows. You'll notice that in my taskbar here, I've got a new little icon that shows up and it says, look, turtle demo, and it looks like a little blank screen. It looks like there's something that I might be able to draw with there. If I click on this, it shows up and it says it's not responding, and like I can't move it around, I can't do anything, and if I click away from it, it's just like I can't really work with it. What we're going to want to do on Windows in order to sort of make sure you can get to that element is you want to make sure that you've got your browser so it's not taking up your full screen. You want your browser to be in sort of a windowed mode. So on my machine, and I haven't done anything special with Windows, so this should be the default behavior. If I double click on the top of the bar there, you'll notice that my window goes into this sort of smaller window mode so that I can be able to have my turtle window thing running sort of up there in the corner. You'll notice that because it looks like it's frozen, it's not responding. Technically, the turtle will keep working, but the window itself is frozen. In order to get to stop doing that, if you go over to this Stop Turtle button that got created by that first cell, if we click on that Stop Turtle button, then you'll notice that this window effectively unfreezes. That sort of ends the program, that finishes it up, so I can then move it over here and I can close that window. So we should be able to, and let's see if I can make this work. Please, I can make this work. Is I should be able to open up this way and then drag it over where I need to go. No! Ah! All right, so it's a little bit finicky on Windows, even using the notebook, but we can at least stop it, and then I don't think I can rerun the turtle. I think if I rerun the turtle again, I think it's gonna make a new window. Yeah, I think that's not gonna work. Oh, no, there's my new window, which again is gonna show up and disappear. So yeah, it's a little bit finicky on Windows. You can sort of move back and forth by having them in windowed mode and sort of being able to like at least jump around to be able to see them both. If you've got multiple screens, that potentially could help. There's a little bit of way. Oh, see, there we go. So I can at least do that kind of thing to be able to move back and forth between them. If you're ever having problems and you get stuck and like things just seem like they're freezing, when in doubt, go to kernel, restart, and clear output, just like we've done previously. That will kill everything. It'll basically shut down the window to make it all work together. Once everything is done sort of restarting, you can then rerun your first cell, reestablish your functions, and then be able to build up your turtle demo to be able to have things go and be able to work together. Great. Cool. So that gets our window. If we actually open up this window, then I want to be able to see, thanks, there we go. You can't really see the turtle because effectively he's actually in this bottom right corner. He's a place that you can't actually be able to see him. So what we can do is we can move him around to get where we need to go. So I'm going to start by using a command called goto, and I'm going to just put in some stuff real fast here so you can be able to see what it looks like. But we can basically use the goto to basically tell that turtle to move to a particular location. So if I execute that code, then you'll notice, if I can get my window back here, I'm not sure how much of this is Windows or how much of this is my virtual machine just crashing on me. Here, we'll just do this. This will work fine for us. Ah, no, not you. Minimize. There we go. You can see that my turtle sort of moved up there and it's this little gray triangle sort of at the corner. If we decide that we don't like the triangle, I can actually use a method called shape and specify that I want to look like a turtle. and then I can actually see that, look, now I have a little turtle icon sort of moving around, and there's the trail that it drew with the pen out of its butt. Yay, great, so that's our turtle, that's our thing we can get to do. It's a little bit awkward to get this up and running, to work the system work, but it's really the best way of letting you do this work without having to run it in a shell script. If you run this from a shell script, so if you define like a .py file and you write all your turtle commands in there, everything works smooth. You don't have to deal with this whole windowing system. It all happens to work out much nicer, but this lets us work within Jupyter, which tends to be a little bit nicer environment for like testing and rerunning things, and you can sort of, move the turtle around in different cells without having to readjust things. Okay, so the way that we're actually going to end up basically telling the turtle to do things, I'll go over this in more detail in a second, is by taking this turtle object, this thing that represents a turtle, that's effectively our virtual turtle variable, and we're going to call methods on it by using the dot notation. So I'd call, for example, goTo to tell it to go to spot 200, 200, and I can tell it to change its shape by specifying what its shape may be. If I call turtle.reset, so if I get rid of these pieces, sorry, let me call them out. So if I get rid of these pieces and I re-execute the cell, that will reset my computer. You can even see the turtle's little foot down there at the corner. But that will basically reset, sort of clear my drawing so I can be able to then start again and do something else. So that now in my next cell, I could, for example, have done my go to 200, 200, and I can basically tell my turtle to go move up around again. You'll notice that because the turtle keeps its shape because I haven't basically restarted the whole thing yet. Great. So yeah, so again, that you can open up these pieces by having them sort of work inside of different windows. If you want to close this thing, if you want to get it ready, you'll notice that even though it seems like it's frozen, I can still tell my turtle to go to other places. Like I can tell them to go to 400, 400, and the turtle continues moving across the screen, even though it looks like the window is dead. Nevertheless, if you want to actually close it and stop your computer and like tell it to do other things, go scroll up to that stop button that appears to have disappeared. So when in doubt, you can take this cell and you can run this stop turtle function, which stops the window. It allows you to manipulate it, and then you can close it, and you should be good to go. If you do have a problem getting the turtle to work, particularly in Windows or something else, I've also set up a playground area on Ed that you'll be able to try this out and see how this works. Effectively, it's a slide that has a runnable module in here that will do the exact same sort of make turtle function and establishes the turtle as best we possibly can inside the browser. So in this case, we can make our turtle. If you click this green run button, then you'll see that my turtle sort of appears up on the screen, and we can tell it to move forward and to sort of run around, and that'll draw the line that we expect. You can click sort of anywhere outside the window to close it, and then you basically have to rerun it as a script. This is the same way you would have to write something as a command script, but this will let you be able to at least play around with the turtle a little bit without necessarily having to get all the setup stuff up and running. You can potentially even do some assignment kinds of work in here to like test with the turtle, but I'm not sure how smoothly it's going to work. I would probably not recommend doing that, but it might be a place to try out and play around with things if you need to. All right, for the rest of this demo, I'm going to show off how things work on the Mac because it's faster than my virtualized Windows machine and tends to be a little bit smoother for my development. So, but again, same process is going to apply in terms of the code we write. It just lets me get the windowing thing out of the way and work a little smoothly. Okay, great. So we have our notebook that's working here. I've got my canvas over here with my spinning ball of death. And I've got my turtle that I've sort of told to look like a turtle and to move up to 200, 200, which is the center of the screen. So let's talk about how we can actually control and move this turtle. So again, the way we're going to interact with the turtle and tell it to do stuff is we're going to call methods on this turtle variable that was declared and created by that make turtle function. So the this turtle variable represents the turtle thing itself, right? The robot that we're programming with the virtual pen. So in general, we can tell this robot to move around by calling different methods on it. So calling different functions using dot notation. So the most basic one that I might use is I could use turtle.forward, which will tell the turtle to move forward. And then I'm going to give it a number, which is going to be how many pixels, so how many spots, basically, I want it to move forward. This window is 400 pixels by 400 pixels. So if I tell it to move 100 pixels, that's going to be 100 out of 400. So it should move a quarter way across the screen. So I can do that work. I could say turtle, move forward 100 pixels. And my turtle moves forward 100 pixels. You notice that my turtle is moving very fast. I've set speed to be fast so we can get through our demo sort of as quickly as possible. So I can tell my turtle to move forward. I can tell my turtle to turn, to rotate in different ways. So I can use turtle.left to tell it to turn to the left. This is going to need to give it an argument. I'm going to need to specify how many degrees I want to turn. So for example, I might say turtle turn 90 degrees to the left. Now we have to remember that if my turtle is looking like this, right, on the screen, if I turn 90 degrees to the left, that's going to be my turtle's left, and it's going to move 90 degrees, so it should be pointing now straight up. So let's do that. Let's do turtle.left 90 degrees. My turtle now turns. He's now pointing straight up. If I told my turtle to then say move forward again by say another 50 pixels, my turtle can move forward. And again, now I'm drawing myself a little path through the page. I can use a turtle.right if I want to turn to the right. I can maybe say let's try rotating 60 degrees to the right. Now he's sort of turned at a slightly canted angle. I can also just use a turtle.rotate method if I want to just specify a sort of degrees, I think counterclockwise. So if I say rotate 60 degrees from there, oop, they don't have a rotate method. Never mind, ignore that. So left and right, forward gets you where there's a back as well, but you know that where it needs to get you where you need to be. Cool. So let's see. Let's do that. Let's reset my turtle. Notice I could reset. I'm going to run my reset cell, resets, sets the shape, moves back to where it wants to be, to that center point. Let's see. Other things we can do. If we want our turtle to, so you'll notice that when I said this turtle to move, he starts at that corner and he moves up to the center, but he leaves this trail behind him. If I want the turtle to move around without leaving a trail, then what I can tell the turtle to do is basically take that pen it's dragging along the ground and to pick up the pen and then move forward and then put the pen back down to start drawing again. So the way I could do that is I could say take my turtle and tell him to lift his pen up, by which I would do that by calling literally a method called pen up. So I'd say turtle, pen up, lift your pen, be done. I can then tell my turtle to say move forward by that 100 pixels again. Then I can tell my turtle to say put his pen back down. So now the turtle's pen is back on the ground. And now I tell the turtle to then say move forward another 50 pixels on top of that. My turtle should be able to move, he'll move up to here. He's starting here. He should move forward 100 pixels without having the pen up, so it should leave no line. Put the pen back down and then draw another short line 50 pixels after that. Let's see it in action. So I'm going to run the cell, and you'll notice my turtle zipped over without anything being drawn, put the pen back down, and then start drawing again. So a common way we might do this is we can go back to my reset cell, and I can tell my turtle to put his pen up before he sort of moves to the middle. This is my move to middle, and then I can say turtle.pen down, so that when I reset him, he moves up to the middle, but without leaving that extra line behind him. Cool. But yeah, so the basic structure, again, you can think of as if you want to move the turtle without leaving a trail, is you're going to lift your pen up, move the turtle, put the pen back down to be able to draw again some more. All right. There's also other things we can do with the turtle. This pen, we can actually change the color and sort of the thickness of the line that's getting drawn. I can use turtle.penColor method to be able to change the color of the turtle's pen. So I can call it, so for example, I could say, let's make it a red pen. And you'll notice that the turtle now has sort of this red outline around it because he's drawing sort of a red line. I'm a little bit bigger fan of using an alternative method that works basically identically the same way, which is called turtle.color. So instead of specifying the pen color, you're going to specify effectively the turtle's both his pen color and the turtle's color. So I can then say my turtle is now red, so he'll draw red stuff, both outline and filled. So I can specify how big that he is. If I then, of course, say my turtle to move forward by my 100 pixels, he moves forward, leaving a red line behind him because he's a red turtle. We can reset. I can tell my turtle to specify how thick his pen is by using what I call a function called pen size. I'll also use width a lot. So pen size and width are the same method. They do the same thing. And we can specify that in terms of how many pixels wide we want to be. So we might say that we want this to be 5 pixels wide. So we want to, again, set that pen size before we tell him to move forward. So we want to say, okay, turtle, become red, grab a bigger brush, and then move forward, dragging your bigger brush. So if we tell him to do that, then he's going to draw this nice big thick line before us. Because he's red and because he's got the thick brush there, until we say change the brush or change your color, anything that I do is going to involve that big thick brush going on. So if I then have the turtle dot turn to the left 90 degrees, and then have him move forward another 50 pixels, he is still drawing this big, thick red brush at the end. Okay, and that's the basic idea of sort of how this works. All right, what else can we do? Let's reset. I'm gonna keep my turtle being black, but I'm gonna actually go ahead and give him a pen size of 5 again, so we'll have him at least draw a thick line so we'll be able to sort of see it in a little bit clearer detail. There we go. All right, let's delete this stuff. Okay, so forward, left, right, those are going to be your main methods that let you sort of maneuver around the page, and I'll get you basically anywhere you need to go. You just have to think about how you effectively would drive a car, right? I would go forward, I'm going to turn left, I'm going to turn right, I'm going to back up, but anywhere you can think of how you would get your vehicle, your car, your bike, yourself from one point A to point B, that's the commands you give to the turtle. That said, one of the most useful methods for sort of skipping some of those complex steps and being able to sort of write effective drawing code is to use this go-to method. So this is what I'm using up here in the beginning where I'm saying move to the middle. So go-to takes 2 arguments. It takes an x-coordinate and a y-coordinate, which are going to be the same as the sort of the Cartesian grid thing you might remember from math class, geometry class that you may have taken in elementary school or something like that. So the idea here is that we have this, you can imagine this sort of imaginary grid, ignore my spinning beach ball, where this corner down here is my location 0, 0 on a Cartesian grid, right? I have my x-axis that goes from 0 up to the width, so 400. My y-axis that goes from 0 up to the height, 400. So the idea is that goTo says what coordinate, where in my graph would I like to move the turtle to? So if I say go to 200, 200, well, 200, it says go to the x spot that was 200, which again, because my width is 400, 200 is half of that, so I'm going to move halfway over. And then it says go up, go to a y coordinate of 200 as well, which again is halfway up. If I adjust this work, let's take my turtle, let's put his pen up while we move around. If I say go to, say, if I say on my x-axis go to 0, right? Don't move any further along my x-axis. So I want to stay right here on the sort of at the 0 point on my x. But I can then say I do want to move, say, 3/4 of the way up. 3/4 of the way up is going to be 3/4 of 400. If you do a little bit of math, it's like, oh, that's going to be 300, right? That's going to be 3/4 of the way there. So I can say move 0 on the x, 300 on the y, and my turtle will then move to that spot on my grid. This will let you be able to sort of jump around individual points as long as you can figure out where they should go sort of in the graph or the coordinate system where you want to draw. You can move the turtle there directly. If we decide to leave our pen up, right, if I move the turtle to the middle and then I didn't put my pen back up, I left my pen down, I can then move him to the corner and he would again draw his big thick line sort of as he moves in that direction. So the turtle is actually moving, but rather than needing to say move 90 degrees, 18 degrees to the left, and then 36.5 pixels forward, we could just say go to this spot and the turtle will go to that spot. So again, the important thing to note here is that these go-to method is not relative. It's not saying move 0 pixels from where on the x from where I am, horizontally from where I am, and then move 300 pixels vertically. It's saying go to spot 0, 300. And that's going to be really useful for basically saying get the turtle to here and then sort of draw a line along the way as you go. Okay, cool. And that's go-to. The last thing I want to sort of cover is that I want to sort of note that again, that controlling this turtle successfully and being able to sort of really understand where it goes and how to move it around involves a little bit of sort of thinking through, basically in some ways pretending to be the turtle and thinking through okay, if I'm standing here, what direction do I need to turn in order to get myself to a particular spot? So let's reset him and let's have him start actually up at that sort of that upper corner. So we're gonna have him start sort of up there, so he'll be ready to go. And then what we then want to do is we can then think through, well, how can I get the turtle to move around? So as an example, let's try to think through how I can get the turtle to draw some zigzags. So let's see if I can get him to sort of draw up, down, up, down, up, down, up, down, up, down, up, down. We can do sort of a Charlie Brownish kind of zigzag pattern across the screen. So we think through, okay, well, I want the turtle to, first thing I want him to do is to go in that direction. So I could either use go to figure out well, what would be the coordinate where I want him to go to? Or we might think, well, I don't know where exactly that coordinate might be, and there's going to be angles, and there's going to be trig, and I don't want to deal with that. But let's just say, let's just have him rotate and sort of move up at a 45-degree angle there. Hopefully everyone's okay with basic angle degree stuff. So we might say, okay, let's have our turtle. Again, I'm facing this direction, and I want to rotate. For me, that's going to be my left, so I'm going to rotate to the left to get me where I need to go there. So my turtle will rotate to the left, and we can say, let's rotate him 45 degrees. Great. And then I could then tell my turtle to move forward. How about let's move forward maybe 50 pixels, and that moves him forward in that direction. Now that he's there, we say like, okay, but now I want him to turn so that he's currently facing like this, but I want him to turn so he's facing that way. If you, again, imagine, like, just look at what your hand is doing. My hand's like, oh, I'm rotating to the right, and that's actually from here to there, that's a 90 degrees turn. So I can say turtle, go to the right by 90 degrees, and then I might say, tell my turtle to move forward by 50 again. Oh, look, we're zigzagging. Now I say, okay, great, now I want to go turn left again, so I need to turn turtle.left 90 degrees, and then I can say, take my turtle and tell him to move forward another 50 pixels, and look, now we're zigzagging. I could keep going by typing this over and over and over again, great, or I might realize that, hey, you know what I could do is that because I'm doing the same thing over and over again, I could use a loop to do this kind of work. Loops, okay, great, let's do it. So let's go ahead, let's reset our turtle. Let's get back to where we started. So we might say, okay, well, initially, the thing that I'm gonna repeat is the forward, right, forward, left, forward, right, forward, left. So let's do that initial turtle.turn to the left. Turtle.left stage, have him move those initial 45 degrees. So we're basically gonna get him started off correctly. I then might say, like, let's go do the zigzag thing. Let's do like 4 hops. So I might say that for each, how about each zig in a range of 4. So we're gonna do this 4 times. We really can call it whatever we want. I'm gonna call it zig. I can then tell my turtle to do the work. We're gonna say, okay, turtle, go forward 50 pixels. Then I want my turtle to go right by 90. So he's going to move. So we've started him off left. He's going to go forward. He's then going to turn to the right 90 degrees. We're then going to tell him to go forward again 50 degrees. And then we're going to tell him to go turtle dot left 90 degrees. Right. So that's going to say, so he starts off this direction. We're going to say go forward, turn right and go forward, then turn left. But now hasn't moved yet, but then we're going to get to the end of our loop. We're going to swoop around to now say go forward again. So the thing to note here is that, like, at this point, my turtle is, the reason that I can just move forward at the start of that loop is because my turtle is already in position. He's already facing the right direction, the same way this first line said, get ready to do a loop. And this one at the end is basically saying, get ready to do the next loop as well. So there's this sort of idea of, like, at the end of one loop, you want to be sort of getting yourself in position or ready to go to do the next loop over. So we can do that, and then we get an issue. I spelled forward wrong, right? Make mistakes, that's okay. We're just going to, let's see, because my turtle's already moved, if I want to rerun this loop, I'm going to make sure that I want to reset it. So I want to bring him back to where he used to be so that my turtle isn't like facing the wrong direction when I get set up. And then I can tell him to move up and around, and now we can start drawing little zigzags. And that's cool. If I decide 4 doesn't quite get me across the screen, I can go ahead and change that to 6. Again, let's reset. Try again. Yeah, there we go. And my turtle drives himself off the screen. It's still working. He's still there, but I can't see anything, so I want to sort of move him back. The other way that we might think about this is that if I reset to here, we might say, like, well, I want my loop to handle the, like, basically I want to say my turtle is currently set up and ready to go. He's facing right. He's in position. He's ready to move. Let's have my program, my function, my loop sort of always work from that starting point. So I might say that what I want to do is each of these 6 times, maybe we'll go 5 so we stay on the screen, is the first thing I want to do is I want to have him turn to the left 45 degrees, right? So that's going to shift him over. He's then going to move forward. I'm then going to turn right 90 degrees, shift him down, he'll move forward. Now I want to basically have him end facing directly right. I don't want to have him end at an angle because then the next thing I do is going to have to work off that weird angle. Let's just have him always end where I started him off, and sort of like, we're always sort of back to, like, it's like back to center. So if you imagine like dancing type things where it's always like, okay, always return to this position, be ready to go off to the next step again. So we might say, like, okay, well, because he was forward-facing sort of down that way at this point, let's have him just rotate the 45 degrees to get back up to where he was, so that when I go do the loop again, because I've already started in my sort of starting flat position, then I can be able to go back, I'll be able to do my 45 degrees and be able to sort of get back where I need to go. So we can basically break up these pieces into different ways. I really recommend being able to think about always return to this position is a good way of being able to make sure that your code is going to be able to be reused and you can move it around and it's not going to cause a bunch of problems. So this way, again, I can run this code and I'm still getting my zigzags, but again, he returns to that position so that if I actually run that cell again, he just keeps zigzagging off the screen, right? I don't have to keep editing where he was, I can just keep rerunning the zigzag. I could even, for example, have him, if we reset him, I could have him run that zigzag, and then I could say to have my turtle do my, let's go to, I could have him say go down to somewhere else, right? Go to 500, let's have him run that zigzag. I can then tell my turtle that I want to go back down to, say, 0, 200. Let's have him move further back down the screen, which I forgot to do something. Go to doesn't actually change his facing, so he's still there. So which means I can actually now rerun my loop again, and I can draw more and more zigzags, and I can basically control the computer. And look, now I have something that almost looks like mouth, teeth biting each other. Yay, fine. Cool. So that's sort of the basics of how to get the turtle to do stuff and how to sort of use a loop to, again, to sort of drive through what the turtle's going to do, which is the kind of things you'll be asked to do in assignments. You're welcome to play around with this. Again, I'll have this notebook available. You can download at the bottom of this video on Ed. You can also play around in the Ed playground area. You can play around with the shell script. If you're looking for a challenge to play with the turtle, my challenge for you is to try to draw a stick figure, like something that's going to be sort of like with 2 legs, a body, 2 arms, and like maybe a square for the head. Though it is possible to draw circles with the turtle. You can look up how that works. It's sort of just a fun thing to try to do and sort of make sure you can feel like, oh yes, I understand how to get the turtle to go to different places. And with that, that should take care of the turtle.